Hey everyone, for math today, your job is to complete pages 224 and 225 in your math journal, so please make sure you go get it. Now, I am asking that you please try and work on these by yourself first. This video is here for you if you need help. I'm going to walk through each problem to help if you need it, but I would like to see what you can do on your own first. So try it out, and then if you want a little bit of help, then come back on this video and scroll through to get help on the problems you need. So, the directions are to solve each problem. Show your work using drawings, number models, or words. Remember to write the unit with each answer. First up, Kiana has 40 inches of green ribbon. She wants to cut it into 9 4-inch pieces to make Earth Day award ribbons. Does Kiana have enough ribbon? All right, well, we need to figure out what we know. First step of solving problems is to figure out, what do we already know? Well, we know she has 40 inches of green ribbon. So if I were to make her ribbon, I know it goes up to 40 inches. All right, we know one thing. What else do we know? She wants to cut it into 9 4-inch pieces. Okay, so she's going to cut it into 9 pieces, each one being 4 inches. The question is, does she have enough ribbon? All right. Well, Kiana, we're here to help. Let's start by cutting this green ribbon into 4-inch pieces. Now, we want to get to 9 4-inch pieces. So let's just start with 1. Okay, 1 piece is 4 inches. If we cut another 4-inch piece, that's the second piece, then we have to add 4 from the first piece plus 4 from the second piece, which has 8 inches in all. All right, well, let's keep going because she needs 9 pieces. Third piece, add 4 more, we're up to 12. Fourth piece, 4 more inches, we're up to 16. If you see what I'm doing and you want to try and solve it on your own from here, go ahead and solve it. I'll keep quiet for a little bit so you can practice it on your own. All right, so here we are at the 9th piece, which when we add 4 more brings us to 36 inches. All right, we have her 9 pieces. Each piece is 4 inches, just like she asked. Does she have enough ribbon? She does, because she has 40 inches, and her 9 pieces only took her to 36 inches. So our answer, yes, Kiana, you have enough. Congratulations. Now, how much ribbon, if any, would she have left over? Okay, well, she cut up to here. Cut, 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 which means she has this much left. 36 plus what equals 40? 36, 37, 38, 39, 40. 36 plus 4. So how much ribbon would she have left over? 4, don't forget your unit, inches. All right, number 2. The city zoo is home to a male African lion. After the lion arrived, he gained about 8 kilograms of mass each month for 8 months. He now has a mass of about 186 kilograms. What was the lion's starting mass? All right, well, again, we have a lot of information, so let's figure out what we already know. Okay, we know that when he arrived at the zoo, he gained 8 kilograms of mass every month for 8 months. So for each of those 8 months, he gained 8 kilograms. He now has a mass of 186 kilograms. What was the lion's starting mass? All right, well, we know his mass now is 186, so that's kind of like the equals. And we don't know how much he started with, because the question is, what was the lion's starting mass? So that's the question mark for us. Do we know how much he gained? He gained about 8 kilograms of mass each month for 8 months. Okay. So there were 8 kilograms every month for 8 months. Wow, this problem looks pretty complex. Question mark plus, in parentheses, 8 times 8 equals 186. But we know from our order of operations that we have to solve what's in the parentheses first. So let's do 8 times 8. 8 times 8 went out the door. 8 times 8 is 64. So we can get rid of our 8 times 8 because we know that equals 64. Now we have a more simple problem to work with. Question mark plus 64 equals 186. I don't know what plus 64 equals 186, but I do know that we can solve this if we take the total mass at the end minus what he gained. Oops, that should say 186. Boop. Okay, so he ended up with 186 kilograms of mass. He gained 64 kilograms of mass. So to find what he starts with, we just need to subtract what he gained from what he ended with. So 6 minus 4 is 2. 8 minus 6 is 2. 1 minus 0 is 1. Answer, about 122. Don't forget the unit, kilograms. kg is a nice way to abbreviate kilograms. All right, nice job. Next up, looks like we have a length of day problem. So Lena has a doctor's appointment at 8:45 a.m. It takes her 25 minutes to drive to her doctor's office. How many minutes early will Lena be if she arrives at 8 o'clock a.m.? Okie dokie. Well, I know with elapsed time, it's really helpful for me to draw a timeline. So that's what I'm going to do. Okay. So her doctor's appointment is at 8:45. That's kind of like the end goal. She needs to make sure she's there by 8:45. She says it takes her 25 minutes to get there. But our question is, how many minutes early will she be if she leaves at 8 o'clock? So her starting time is 8 o'clock. Let's say she leaves at 8 o'clock. How long does it take her to get there? It takes her 25 minutes to get there. So what's 8 o'clock plus 25? 8 plus 25 is 8:25. Oh, okay. But be careful, the answer is not 8:25 because the question is asking how many minutes early will she be if she leaves at 8 o'clock? So if she leaves at 8 o'clock, she's going to be there by 8:25. Her appointment doesn't start until 8:45. So we now need to figure out what is the difference between 8:25 and 8:45. 8:25 plus what equals 8:45? Well, just like when we do elapsed time at school, you don't have to know the exact difference. We can take it in smaller steps. I like adding tens because that's pretty easy for my brain to understand. So if I do 8:25 plus 10, I know I'd be there at 8:35. Okay, still too early. So I need to add some more. Let's do another 10. Adding another 10, 8:35 plus 10 is 8:45. Oh, nice. Okay, so then I added 2 tens. 10 plus 10. We have our answer. She'll get there about 20 minutes early. Awesome. And then we have a bonus question. At what time must Lena leave to arrive at exactly 8:45 a.m.? All right, I'm going to erase this so it doesn't confuse us. So now she wants to arrive exactly at 8:45, which just means we need to subtract the time it takes her to get there from the total. So 8:45, how long does it take her to get there? That's right, it takes her 25 minutes. You might know 8:45 minus 25 off the top of your head, but if you don't, we can take it in smaller steps. So let's take this 25, and let's just take 5 of that. 8:45 minus 5 minutes, minus 5, would bring us to 8:40. Okay, if I take 5 minutes, then I'm left with 20 minutes. I can minus 20 from 8:40. 8:40 minus 20 minutes brings us to 8:20. And then you see here, 20 and 5 makes 25. So this is kind of like elapsed time backwards. It still works the same way. It just kind of makes your brain have to switch gears. So at what time must Lena leave to arrive at exactly 8:45? The answer, 8:20 a.m. All right, go ahead and flip now to page 225 where we can do our last 2 problems. All right, for problems 4 and 5, use the pictures to help you solve. How much more liquid is in beaker B than in beaker A? All right, to solve this, we need to start by figuring out how much liquid is in each one. So, beaker A. Let's look at how high the water goes. Boop. What number is it on? 500. Beaker A has 500 milliliters of water. All right, let's look at beaker B. Beaker B, All right, the water goes in between 600 and 700. So, if the water's halfway between 6 and 700, what number comes halfway between 600 and 700? 650. So beaker B has 650 milliliters of water. Now to find the difference, we need to take the liquid from beaker B and minus the liquid from beaker A to give us this difference here. So 650 minus 500, 0 minus 0 is 0. 5 minus 0 is 5. 6 minus 5 is 1. About 150, don't forget the unit, milliliters. That's how much more liquid is in beaker B than in beaker A. Cool. All right, last but not least, number 5. Tomas wants to figure out the liquid volume of his glass. He fills a 50 milliliter beaker with water and empties it into his glass 4 times. His glass is now full of water. Then Tomas empties his glass into a 1 liter beaker. Shade the beaker to show how much water is in his glass. Okie dokie. So he has a glass, and we don't know how much it holds. Question mark. But we do know that he's using a little 50 milliliter beaker and he's emptying it into his glass 4 times. When he does it 4 times, his glass is full. So if this is Tomas's beaker, he's taking his 50 milliliter beaker, a little one, and he's pouring it into the glass 4 times. So let's say he poured it in 1 time. That would be 50 because that beaker was 50 milliliters. But he didn't do it 1 time, he did it 4 times. So if we poured in another 50, he would be at 100 milliliters. If he poured in another 50, he'd be at 150 milliliters. And then the 4th 50 milliliter of beaker would bring him to 200 milliliters. Okay. Then Tomas empties his glass into a 1 liter beaker. Okay, check this out over here. This says 1,000 milliliters, but here's a little tip for life for you. 1,000 milliliters is the same thing as 1 liter. Those are equal. So he can pour his 200 milliliters into this beaker to see how high it goes. Now, we already figured out it's 200 milliliters. So if he poured it in and we had to shade it in, it would go up to the 200 milliliters. This beaker is way bigger than his glass is. So even though his glass is full, it only takes up 200 milliliters of the 1,000 milliliter or 1 liter beaker. Yeah, up to the 200. Nice. So the answer, Thomas's glass holds about how much water? 200 milliliters. All right, friends, nice job working with me on your math today. That's all I have for you, so I will see you next time. Bye, guys.